Welcome to qnawire.
In this problem, we have a plane flying on a banked curve, and we have to find the magnitude of the lifting force, or the force under a plane's wings that keeps it airborne, that we need in order to fly at this radius and velocity. So if we draw a free body diagram of our plane, we have the gravitational force pointing downward and the normal force pointing perpendicular to our banked curve, like this. Now, in a more detailed diagram, we can see that our normal force must be equal to the sum of a y component and an x component, with the angle theta between them here. Now, we can see that our y component must be counteracting the force of gravity, since it is pointing straight upward. And based on our more detailed diagram, where we split up the forces, we can see that this must also be equal to Fn times the cosine of theta. Or, sorry, not Fn in this case, Fl, our lifting force, since we're not on the ground. Now, our x component is pointing straight inward towards the center of our circular motion, so it must be equal to the centripetal force. And based on the trigonometry of our problem, it is also equal to sine theta of our problem. Now, we can solve for the lifting force itself in terms of mg based on our y component. It must be mg divided by cos theta. And that means that we can rewrite a horizontal component as well as mg tan of theta, since the tangent is just equal to sine of theta divided by cosine of theta. As we said earlier, that is equal to the centripetal force, mv squared over r. Now, we can cancel out our m's. And even though FL isn't in our problem anymore, as we know from earlier, FL is equal to mg over cos theta. So we are going to solve the equation that we have now for theta in order to solve the problem as a whole. So let's rearrange to isolate tan of theta and get that tan of theta equals v squared over r times g. And when we plug in the numbers that we're given, which is that we are traveling at 123 meters per second squared, and our radius is 3,810 meters, and multiplied by 9.8 meters per second squared, we find that theta is equal to 22.048 degrees using the inverse tangent function. So tan negative 1 of theta. All that's left to do now is to plug in. We know from earlier that FL equals mg over cos of theta. We're given the mass of the plane as 2 times 10 to the 5th kilograms times 9.8 meters per second divided by cosine of that angle that we just found. And plugging all this into our calculator, we find that it is equal to 2.115 times 10 to the power of 6. Our units are meters times, kilograms times meters per second squared, which is equal to newtons, the units of force. So our answer makes sense, and this is our value for the lifting force.